Good day. Today I have an exciting topic with you to share. It's bovine hypocalcemia. Why is calcium an issue in the fresh cow? It's quite obvious when you think about it that calcium potentially is an issue because the cow needs about 3 times more calcium just after calving than she needs before calving. The 20-liter or so colostrum what a cow produces requires 50 grams of calcium, and that's actually 10 times more what she has circulating in her blood. So we have two distinct features we can encounter. We can have the clinical milk fever, we're all familiar with, and we have the subclinical hypocalcemia. The subclinical hypocalcemia, as the name suggests, is a little bit more subtle, but it has serious signs like lower milk production, dystocia, retained placenta, displaced apomasum, clinical mastitis, ketosis, and last but not least, low calcium weakens the immune system. And we all know how important a good functioning immune system is in the fresh cow. Hypocalcemia is really not a very rare occurrence. In this study done on 1,462 cows, we noticed that third lactation and up cows really see a lot more milk fevers, and second lactations and up start showing a lot more subclinical hypocalcemia. One of the hormones to keep in mind is PTH. PTH is really important in regulating calcium. The regulation of calcium is improving with a mild systemic acidosis, what we can create by giving boluses and by giving anionic salts. The target tissues for PTH are bone, salivary glands, and kidneys. And the kidneys are an important factor in the metabolism and the regulation of calcium. It helps the tubular reabsorption of calcium, and it also plays a role in the vitamin D production. And vitamin D production is needed to absorb calcium from the intestines. What does a good bolus look like? A good bolus provides calcium rapidly, dissolves rapidly, supplies a sufficient amount of calcium, creates a mild acidosis to increase the sensitivity of the receptors to PTH, and last but not least, it should be safe. As a side note, never ever use broken boluses because the calcium chloride and the calcium sulfate that is in these boluses should be protected by a protective layer. We have 5 boluses listed here, and I'd like to go through this list with you. All boluses contain calcium chloride, a rapid source of calcium. Some of the boluses contain another rapid source of calcium, calcium sulfate, the CalBoost, the Bovicalc, and the Dr. Register. Calcium carbonate, we all know calcium carbonate. It's limestone, it's in dairy rations. It's a good source of calcium, but it is a very slow source of calcium, and we get into that in a few next slides. Calcium propionate is another calcium source, a little slower than the sulfate, but as you notice here, the amount of calcium propionate in the bolus is very small. In a study that was published comparing a bolus with calcium propionate to a bolus without calcium propionate showed actually that there was no real benefit in preventing ketosis by the addition of a small amount of calcium propionate. Magnesium oxide is in one of the boluses. and it is in our dairy ration as well, but in a lot higher amount. So this again is a very minute amount and probably not going to add a lot as far as the buffering capacity, but it has a little bit of magnesium in it. Vitamin D3 in 3 of the 5 boluses, and it gets us to the total calcium. The total calcium looks like similar for most boluses, but one bolus stands out with 54.3 grams. But I like to point back to you the fact that calcium carbonate is a major contributor to the amount of calcium. So when we look at the rapidly available calcium in the bolus, we see for CalBoost 43, Bovacal 40.7, so fairly similar. Transition a little lower at 35.9, and RumiLife quite a bit lower at 25.1, and last but not least, Dr. Register was 46.7. So when we look at the coating, one bolus has 2 coatings, 3 boluses have 1 coating, and Dr. Register has none. We talked about calcium chloride and calcium carbonate. I'd like to point out 2 things in this slide. The first thing is that after we give up the calcium chloride, in this particular case as a drench in a liquid, and we have here on this axis the increase of calcium compared to the baseline, we'll see that the calcium chloride peaks rapidly within an hour, while when we look at the calcium carbonate, it takes basically at least 5 hours to get a very modest peak, what is actually a return to the normal calcium baseline for this particular cow. There is a difference in transport of calcium too. The calcium chloride and the calcium sulfate get absorbed passively between the cells in the rumen going to the blood. The thing to remember here, it is a matter of the gradient between the concentration in the rumen and the concentration in the blood. So cows that have a low calcium in the blood and a high concentration in the rumen will attract more calcium into the blood than cows that have a little higher level of calcium in their blood. The calcium carbonate is an active process of absorption. It goes through the cell, in the cell, and it happens the absorption happens past the rumen in the intestinal tract. It takes time for the calcium carbonate to go from the rumen to the intestinal tract, and this makes the process slower than the ones shown with the calcium chloride and the calcium sulfate. We did a study in Alberta with fistulated animals, and we used 3 boluses. We had the bolus CalBoost, Transition, and RumiLife. We put those boluses in a net. We weighed the net and the bolus. We put the bolus into the fistulated animal in the rumen, and we took the bolus out every 30 minutes, weighed the bolus, and put it back in. We also, as a side note, monitored the rumen pH, and the rumen pH did not really change hardly at all during the experiment. So the first thing I like to point out is that the boluses are similar in weight at the start. After 30 minutes, the boluses are all heavier, and that is due to the absorption of water. And we'll see after 90 minutes that CalBoost is fully dissolved. We see transition boluses are fully dissolved after 180 minutes, and we see that RumiLife after 240 minutes, 4 hours, still is basically the same weight as when it started. This is how it looks like. On the left, you see CalBoost in the net. Nothing is left. There's only the coating left. The transition bolus is well on its way to get dissolved. And the RumiLife bolus, after 90 minutes, almost looks like it started. We were curious what really the effects of the different boluses were in an actual dairy cow, in an actual dairy operation. So we went to Quebec and we compared 3 different bolus regimens. We had the Calbus group, where we used 1 bolus after calving and another bolus 12 hours later. We had a Calbus group where we gave 2 boluses right after calving at once. And we had the Rumilife group where we gave 2 boluses right after calving as well. 6 blood samples were taken for each cow in the first 24 hours. Our thoughts were that with Rumilife we would not see a rapid increase in serum calcium due to the limestone, and we expected with CalBoost that we would get a higher serum calcium peak. These are the results. You see the dark blue line on the graph here, and on the axis here we have the change in serum calcium after the treatment. So just as before, we noticed a peak after 1 hour, but we'll see that the peak with the 1 bolus of CalBoost is quite a bit lower than the peak with 2 CalBoost boluses at once. The other thing what we see with the 2 bolus regimen here is that over the entire 24 hours, we see an increase of calcium. The green line is the 2 Rumilife boluses. It takes, again, in this study as well, longer to get to a peak. The peak is quite a bit lower than the peak with the 2 CalBoost, and the Rumilife maintains at a level higher than the starting value as well. We are in the process of publishing this study, and we did the stats as well to compare the 3 regimens. The one thing I like to point out, the blue line again is the 2 CalBoost at once. The black line is the Rumilife, 2 Rumilife at once. And important for you as a producer to know is that it is highly significant in the first 6 hours, the difference in calcium increases between the CalBoost and the Rumilife. What is also interesting to note is that there is a distinctive advantage giving 2 calcium boluses, the 2 CalBoost boluses, when compared to giving 1 CalBoost followed by another CalBoost 12 hours later. There are 4 different points rather, where there is a statistical difference in the increase by the 2 CalBoost versus the 1 CalBoost followed by 1 12 hours later. So when we're looking at the herd approach, when do we need to administer it? It is a good tool to help prevent clinical milk fever before the cow goes down. We do recommend, based on our studies and the safety studies we have reviewed, that 2 boluses as an initial treatment, followed possibly, depending on the amount of calcium issues on the farm, by 12 to 24 hours later. Another interesting study that I will not go into due to time today is that quite a few producers, when the cow isn't looking quite right and she's after calving, that people want to give her an IV treatment of calcium. That study showed that after the initial spike caused by the IV treatment, there is quite a drop in calcium, what may explain why some of your cows go down 24 to 48 hours after the initial treatment of a cow that doesn't quite look right with an IV treatment. We recommend, based on that study, and that's what the researchers recommended as well, that given a bolus to a cow when she is up and around, followed by possibly a second bolus 12 hours later, is a better way to go. Thirdly, the boluses may be an option for chronic subclinical hypocalcemia. More research is done at this point as we speak, but it seems a logical solution for cows that are not able to get out of the situation having a low blood calcium. We all want to know whether it pays to give boluses. I like to get your eyes trained on the second bullet point, where we see a return on investment listed for the 4 different scenarios. The study from Gary Utzel, what was done in a very well-managed, 2 very well-managed herds with very low number of cows with subclinical hypocalcemia, showed that cows benefited most were the cows that were lame during the dry period, or cows that were producing more milk than their herd mates in the previous lactation. Let me explain to you what a 0.3 to 1 return on investment means. This means in this paper that when you spend $1,000 on boluses, you get an additional $300 back. So the 0.3 to 1 is still a positive return on investment. One of my final slides is showing you another study confirming the health effects that one can see by giving calcium supplementation. I like to note that this was only given once, but when you notice the amount of calcium packed in this bolus, these boluses pack more calcium than the boluses on the Canadian market. In red, I like to point your attention to the fact that heifers in this study too, when they calve at 22 to 24 months of age, do not benefit from getting a calcium supplementation. Other studies confirmed the same sentiment. My final slide shows a herd approach, and this herd approach is not something I'd like you to take to the bank. This herd approach is something as a suggestion for you to start talking to your veterinarian, your nutritionist, or other advisors to come to an approach of what and how to deal with calcium. Quite simply, we have made the distinction between hardly any calcium issues, hardly any milk fevers, like on the Utzel study, where the return on investment was calculated from, cows with low to medium amount of milk fevers, and cows that have a high incidence of milk fever. The thing to remember here is that when you have very few cases of milk fever and everything is under perfect control, the argument can be made that only the lame cows and high-producing cows should be treated. When we go to the right side, when we have a lot of calcium issues on the dairy farm, you have to really start digging into the problem, talk to your nutritionist, make possibly some changes in your ration, use anionic salts or other things like Exolite. I like to conclude by saying that I hope you will understand that not all calcium boluses are the same. I like to stress the importance of getting calcium available to cow as soon as possible after calving. And I'd like you to rethink the practice of giving IV calcium or sub-Q calcium for that matter, because that does the same thing, to cows that are up and around but don't look quite right. Thank you for your attention.